so hello everyone. My name is Eric Smith. As you heard already, I got my bachelor's in poetry, creative writing at U of H, and about 11 years ago I taught myself programming, and just this year I got my master's in computer information systems. So it's been a long journey, a lot of right brain, left brain kind of traversals, and I think that it's given me a different way of looking at programming, and one that I'd like to give you a glimpse of tonight. So when I first started programming, I was very interested in files and bytes and binary, and people that I reached out to see how to learn more about these. There was two pieces of advice that they gave me. One was, there's no point, you don't need to go down that far on the byte level, and if you don't know why you're going down to the byte level, then you're not ready for it. And that was probably good advice, but frustrating to hear at the time. So I didn't get back there for a while, but a couple of years ago I finally did, and what I saw was beautiful, and I want to tell you how it has changed the way that I look at computers, working with data, and ETL files, just all sorts of things like that. So I know that here we have all sorts of different skill levels. So for the people who have already gone down to bits and byte levels, I'm going to try to, if you've never gone down, I'm going to try to demystify it. If you've already gone down that far, I'm going to try to mystify it. So we'll start off with talking a little bit about physical limitations. And the analogy I'm going to use is a chessboard. So we've got an 8x8 grid, and a certain number of pieces, certain number of tiles on the board. It's a finite grid, and because it's finite, that also means that there's a finite number of chess games that could be played. And even though that number is just astronomical, it's a matter of fact that because the inputs are finite, the output will eventually be finite as well. And so a similar principle applies to our computers. And so, like, for example, we've got a screen here, and there's a certain number of pixels on this grid. And you could imagine that if I was to display all sorts of wonderful pictures for you, we could cycle through every picture possible even. But there would be a finite number of pictures that we could eventually arrive at. And I guess the most important piece that I want to add to that is that it would be up to us to provide the meaning of which pictures were valid pictures and which of them were random static. And I think that's a really interesting point, that the computer doesn't really care, doesn't really know which ones are the random generated noise and which ones are a picture of a chessboard or a picture of you or anything like that. We add that layer when we work with the computers, at least for now. And so at their core, probably the biggest physical limitation that computers have is that they only understand numbers, specifically 0 and 1. And the person who came up with the binary that has taken our modern world by storm, his name was Claude Shannon. And when he was 21, for his thesis at MIT, he made a connection between Boolean algebra and the on-off nature of electricity. So we take this algebraic way of thinking and we can ground it in physical reality with electricity. And through that we can create and consume all sorts of digital media. So here is a picture of Claude Shannon. It's a black and white picture, of course. And, so because binary numbers can be so large, we've had to come up with some creative ways to kind of group them and think about them as logical units. So the first one that we came up with was the byte, and there was a bit of, some people had different size bytes, and what we've arrived at, standardized is 8 digits, 8 binary digits, and you can see down here, I've got the first, I've got every possible combination of 0 and 1 for 8 digits here, and that comes to 256. From 0 up to 255 is 256 combinations of zeros and ones. And the important part here is to point out that as the talk is called Essence and Expression, the way that I have started to think about it is that these are referring to the same underlying essence. It's a number, right? And in base 2, you would write it with 8 ones in a row, and in base 10, you would write it with the number 255. But it's the same core, the same essence. And these are just two different expressions of that essence. And with those different expressions, you can do different things with them. They're good at different things. Like for us, the base 10 might be easier to do math than with base 2, for example. Or with base 2, you might be quicker to turn it into a file and consume it through an entirely different way than number. So if you think about it, we've got bytes and we've got binary and we've got numbers. So we're starting to get a number of things together here, but the point I want to drive home is that this file, all files on your computer, are literally zeros and ones under the hood. And when I used to hear that, it's kind of like you went in one ear and out the other, but there's a reality to that it quite literally is nothing but zeros and ones. Every file you have, every application you use, everything that appears on your screen, you can break it down to the zeros and ones. And just the same way how you saw that you can switch from binary to base 10 and have those different expressions, you can take a file and you can break the binary in it. And usually when we got binary of bytes, and we talk about them like kilobytes or gigabytes, right? It's how many bytes. We think of the byte as the logical unit, but you could also kind of flip that upside down, and you think of the entire file as one large binary number. And the implications of that are wild. I'm going into that. So, for example, that picture of Claude Shannon that we have right here, I'm going to take the bytes out of that file. Just open, read bytes here, and then I'm going to show you that there's the 28 some change kilobytes of that file. So now I've got some variables that hold the bytes for me. And then I'm going to turn those bytes to binary. So we can see here's the first 125 bytes of that Claude Shannon file, right? So if you put these ones and zeros in this particular order, you would eventually create that picture of Claude Shannon exactly the way you see it there. But we can also take it one step further and you say that, okay, now it's not the binary, but we're going to change it to base 10. And so here's the first 1,000 digits of the Claude Shannon picture if we were to extract the bytes, consider it as a base 10 integer instead of a base 2 integer. You all still with me? Okay. It's a very big number, right? I'm just showing you the first 1,000 digits here. There's 71,000 base 10 digits to that picture of Claude Shannon. So I guess you could say a picture of Claude Shannon is worth 71,000 base 10 digits, right? And you know, thinking, breaking it down, every file is made up of bytes. Bytes are just a way to group binary numbers. And binary numbers are indeed numbers, just like the decimal numbers we use every day. Therefore, every file is a number. A single, very large number. As in, it is possible to throw a dart at a number line from 0 to infinity and hit something that represents your favorite picture, right? That's crazy to imagine, like, oh, here's the number 5, and that you can think of it as another way, and it's a picture now. But it is, under the hood, it's just a clever way that we've come up with to reinterpret numbers. So does that mean that we can do math with pictures? And the answer is yes, we absolutely can. So I'm going to do just that. So we've already extracted the bytes, turned it into a number, and I'm going to add 1 to that number here. And I'm going to show you the difference that makes between those two pictures. So I'm adding 1 to that number, and then I'm reinterpreting that as binary and throwing it into the bytes of a file, and having some helper functions in there to make it all possible. So here's the original picture again, and here's what happens if we add 1 to it. So as you can see, there's not much of a difference between those two numbers on the road to infinity. So let's try adding a larger number until we get to the point that we can see a visible difference. So this time, instead of just adding 1, I'm going to add 10 to the 10,000. And as you can see, we can see a visible difference here. And if you looked into the JPEG file format, you'd be able to understand kind of why it looks the way it looks. And it's that's an interesting thing, but far outside the scope of what I want to talk about today. And just to give an idea of how big of a number I had to add to make this relatively small difference in the pictures, I mean, you could crop that out and you would see the same picture. 10 to the 10,000 is gigantic. If you were to estimate how many chess games there are, you would come out to about 10 to the 120. And it was Claude Shannon who estimated that number originally. So 10 to the 120 versus 10 to the 10,000, it's a big difference between those two numbers, not even in the same ballpark. So it just strikes me that when you share a picture with a friend or something, it's like we're taking this gigantic number and we're saying, hey, check this out, if you were to interpret it as a picture. Just the idea of that is very interesting to me. So we've added, to pictures, we get different pictures. Does that mean we can subtract from pictures as well? Of course, it's just a number. And at least sometimes. Things start to break down at this level of abstraction. And so I'm glossing over a lot of information on all that goes into what it takes to make a file format a standardized thing that people can rely upon and know, okay, this byte is the header and I'm gonna have the content of the file here and know what to do with it. That's why we think of bytes as individual units instead of long numbers, but you can do the math with them because at the end of the day, it's just a number. So it took me a while to find two pictures that would work for this next one, but it works. And so for this next one, I chose a portrait of William Shakespeare, because if Claude Shannon is the head, then Shakespeare is the heart. And so I have a black and white picture for Shannon, and I have a color portrait for Shakespeare. And, obviously, poet, Shakespeare, now it helps that I found two pictures that were the same size, right? That helps this to actually work, that it ends up as a picture at the end instead of random nonsense that the computer can't interpret as a picture. we can go ahead and we turn that William Shakespeare portrait into a integer and then subtract Claude Shannon from it. And now we've got Shakespeare minus Shannon equals Shakespeare Shannon. So that's awesome, in my opinion. That's pretty cool that we can do that. And so you can get specific on why the picture looks the way it does, right? I've got some calculations here of exactly how much bigger the Shakespeare picture is from the Shannon picture, and it's quite a bit bigger, and it comes out that, roughly the top 23% or so of the picture is how much bigger of a number the Shakespeare picture is from the Shannon picture, which is why it seems like that first part is untouched. It's the most important part of that picture is in those the high parts of the number. So at this point, it begs the question: are we talking about pictures or numbers? And the answer is that it's both. It's just which way do you want to interpret it. So as I said at the beginning, this is not something that's unique to picture files. It is every single file on your computer. So I think that the oddity of this way of looking at things really starts to become apparent when you look at text files, which are the simplest files on a computer, or at least one of the simplest. So I'll break it out step by step. Here I've got an original message, hello world in space, right? And then I'm going to open a text file and write that, just the text, to the file. And then I'm going to open that same file again, and I'm going to read out the bytes that I just wrote up here. And so then I'm going to print those bytes out. So we've got, the bytes there, and that is HELLO space WORLD space. And you can see that the spaces are the same there, right? Like there's a method to this madness that we've gotten ourselves into. And so then I'm going to take the bytes and I'm going to turn it into base 10, and it's that. That's how you say hello world space in base 10. And then I add 1 to that, so the only thing I've changed is the 4 now is 5, and then I turn that base 10 back into binary, so the only difference between these two is the 0 versus the 1 at the end, right? And then I'm going to write those bytes to a new file. And then I open up the new file as text and see what I just wrote. And it's hello world with an exclamation mark. And this just so happens to be the case because space comes right before exclamation mark in the UTF-8. So that's why that kind of dissension and then ascension works the way that it does. But as you can tell, here at this last step, the point I want to drive home is that I did not write the words hello world exclamation mark to the file. I wrote the bytes to the file, and those bytes came from a number. So that means that even though in this case we started with text and extracted and turned it into a number and added 1 to it, we could have just started with a number. For example, a number like this, a very large number. And if I write this to a file, then it comes out and says, I love you, Holly. That's my wife, Holly, there. And obviously reading a number like 6 gazillion, yada yada, does not feel quite the same as reading I love you, Holly, if you were to send that in a text message. But it is the same underlying essence, right? That they are expressing something, different directions. You can do different things with those, but at their core, it's the same essence. And you got to be careful that you send the correct number in that case, because every different number is going to have a slightly different ending to it in this case. So I think that's really quite interesting that you can go back and forth between these different file types and data types. And at the end of the day, it's all just zeros and ones. So I'm gonna think outside the hard drive at this point, because this is where I want to start talking about the implications of what I'm talking about, the theory of it. By this point, you may have comfortably wrapped your head around the fact that all files can be thought of as just big numbers. They're file extension hoods, which is useful for programming party tricks like subtracting pictures from one another, but it's just the context for larger questions, like if you can take a file and you think of that as just one number, and you can also take a folder and compress it and turn it into a zip file, now you've got an entire folder's worth of contents boiled down to one even larger number, right? Because obviously a zip file is still a file, and all files are numbers, so at this point you could theoretically take every song you've ever loved, every note you ever wrote, every movie that ever moved you, and put it into a folder and zip it up and compress it and boil it down, the content of an entire life in one number. For example, online we have the complete works of William Shakespeare, and everything that he ever wrote or wanted to tell to us. You can go in here and read, right? And that website there is being hosted on GitHub. And here on GitHub, you can just come over to the top and download a zip file. So now we've got everything Shakespeare ever did as a single number, which, in my opinion, makes it a lot easier to wrap your head around the infinite monkey theorem, which says that eventually, given enough time, and monkeys in a room would eventually write the works of William Shakespeare. You just give those monkeys a single button that adds 1, plus 1, plus 1, plus 1, and eventually they're going to hit the number that Shakespeare's entire works could be interpreted as a zip file in HTML as, right? So in that way, now we've got not just single files are numbers, but also entire folders and entire life works. It can all be thought of as just one number, and because you can go in both directions, that means that you could start with a number, interpret it as if it were a zip file, and see what was inside that number. So like this completely randomly chosen number, right? I turned that into a zip file, and inside that number was a folder called surprise exclamation mark, and inside that folder was a text file called open.txt, and inside open.txt was some text that says, "You are the answer you seek." This idea that every digital file on your computer is ultimately nothing more than a number opens up some startling possibilities and ways of thinking. Is why limit ourselves to content that already exists? So for example, somewhere on this screen is a collection of pixels and framing that you would someday recognize as the last picture ever taken of you, right? That exists somewhere on the road to infinity. There is a picture that has not been taken yet. We just don't know how to get there until someone actually takes the picture. And you can just imagine picking a number as arbitrary as a single atom in a grain of sand, and you call that number an MP3 file, and now it's a song that was never written, or a movie that was never filmed, or, I mean, the sky's the limit. You could even take it further, where you think about content that won't exist, right? With the last picture of you, that's something that will someday exist, but you can also, somewhere out there on the number line is an entire photo album of you and a life that ended up of a choice that you didn't take, right? It's somewhere on that number line is a collection of bits that you would interpret that way. You would add that layer of meaning, but I mean, where do you stop? How do you, the medium of binary numbers is this unbounded canvas for every conceivable expression, not just of pictures, but of sound and movies and everything that goes on a computer, right? So what if by venturing far enough down this number line, we eventually find new file formats entirely, right? Someone had to come up with an Excel file and like define what that was. Eventually, we're gonna hit file formats that don't exist. Like what if the VR of the future utilizes a special file format and they call it a dot moment, and it perfectly encapsulates all the sights and the sound and the smells of whatever this moment is for you. And then you get a bunch of moments together and you call that a dot life. It's a zip file of sorts. Now while I remain cautious, to say the least, about embracing things like simulation hypothesis or that sort of thing, I think that it is profound enough to realize that everything that can be, everything that ever was and won't be, it's out there for those bold enough to search. But how do you go about searching through literal infinity? And I've got the answer for that. So I've got a little bit of Python here, and I've picked out where I believe the number of zip files start. It's just an empty folder with an empty text file in it, and you zip that up, and that's this number. And while true, I'm not going to run this, just I think it would crash everything. So it's going to add 1 to that number, it's going to turn that number into a file, and then it's going to unpack that zip file and see what was inside. If they found something, if it was a valid zip file, then it's going to print out the number that it found it at and what was inside. So, you know, you can find all sorts of things in here. You just set this on a, set this forever, and it'll get to everything that you could possibly imagine. This code here can theoretically create literally everything possible on a computer. It's the last program ever written.
What if you replace the linear thing with just randomly generated?
You could, and that would be kind of like the infinite function
Yeah.
there of that. Absolutely, absolutely you could.
How long would it take for your computer to catch fire?
Probably a couple of seconds.
How often do you actually find the
I have not run this yet, except for accidentally in preparation for this. I restarted and ran all the cells. I'm like, oh no, gotta stop that last cell. So at first glance, the fact that everything can be reduced to individual numbers seems to cheapen things, right? Like the fact that no matter what you do in this life, everything can be compressed, compiled, numerified eventually, even if your contributions to humanity are as profound and life-changing as someone like William Shakespeare or Claude Shannon, that it's all going to eventually be just one number, a zip file of a zip file, a folder of a folder or something. It seems to like cheapen the dedication and the process that it took to create those things in the first place. But then you start to realize how much absolute junk a program like this would create. To call it a needle in a haystack is trivializing the search. Because, as I started with, we're the ones who provide the meaning to it, right? It's going to come up with every combination, but how do you know which ones are the good ones? Even if it knows it's a file format that's valid, how do you know which ones are the ones that are actually worth opening? Right? Who wants to like set this loose and then 10 years from now you got a movie and you're like, yeah, let's watch the movie, and you sit down and it's bringing you to the brink of tears at the climax, and suddenly the main character is a jar of mayonnaise, and that's a valid format, and that was going to happen somewhere on the road to infinity, but that's not something you want to sit through the process of watching only for it to be, you know, taking a left turn at Albuquerque at the end. So the problem with infinity isn't generating the results. This is, what, 18 lines of Python? It's in sifting through the results. So infinity, when examined up close, starts to look more and more like nothing at all, which completes the circle. Like for example, I'm taking a recording of this right now, and that recording, I'd argue that it was a lot easier and more fun to just stand up here in front of you and talk, rather than set this code loose and eventually arrive at the program that, eventually arrive at the file that, the number that would turn into this file. So it turns out creation isn't just the most exciting path, it's also the path of least resistance. So, we've come a long way, deep into theory and possibilities, and a lot of different directions I've gone. And I want to give you some practical advice on how you can think about things and use this in your day-to-day life. So the one thing to remember is what I said at the beginning, that each expression has a, you know, whether it's text or you interpret it as a number or whether you interpret it as a picture, they all have different things that they are good at and that you can utilize them for. So things like data types or file extensions, those are just the clothes that the bits and binary are temporarily wearing. It's a hint to the computer how to interpret. Every file is the same file. It's all just a number, and you give it these little hints like a header or an extension to tell it how to interpret that number. So, you know, imagine there was a situation, like anytime you hit a constraint or some, because, you know, all of programming is we're working with data. So imagine you're working with an outside system that you don't control. And like it's a gaming, you know, you're making an online game, and it allows you to store a high score as an integer there. And what you actually want is not a single integer, but you want an entire dictionary of values and keys and values. And that's okay. All you have to do is take the dictionary you want, turn it into text, turn that into a number, save the number as if it was the high score, and then when you're done with, when you want to unpack that, just reverse the process. I guess you may need to get creative with these things, but when you understand that at the bedrock of data is this zeros and ones that everything is, you can go in infinite directions, whether it's increasing the underlying number or changing the way that you interpret that number. It's infinity in all directions. So with that said, I'm done with my talk, and I'll take some questions and answers.
Thank you so much. Do you have questions for us, Peter?
Yeah, I was just curious how you got to the empty zip file exactly. What was that exactly?
What is it?
The empty zip file start?
Oh, I made it, and then I figured out what number it was, and then I pasted the number there. I went in the creation pattern, obviously.
Yeah.
Right?
So you created an empty zip file and then you read the bytes basically of
Yeah.
it and then you converted that to integer?
Exactly the same process that I did up here.
Ah,
You make the file that I would say is where zip files start, and then bytes, digits,
Hmm.
right?
So if we were in the Matrix, what you're saying is where each one of us can be summed up as just one really big.
That's exactly what I'm saying. You heard it. You heard it well. That's exactly what I'm saying. Yes.
So when you converted this to numbers, while you're playing around with this, do you find the act of adding or subtracting or something mathematical operator more kind of interesting?
Yeah, subtracting two pictures from one another was definitely difficult. I didn't know that it would actually ever work. Like, I know that it works in theory, but that the result actually turns out as a, like, that's a valid picture, right? It's not a very good one, in my opinion, the meaning that I attach to that. Although, I guess it is a good one in that it's perfectly representative for a talk like this, that this sort of thing is possible. Meaning can change over time as well. Yes?
Did you try uncompressed images like EMP or TIFF?
Yeah, so I tried a number of different things. There's a lot of JPEG on the internet, and finding two pictures of Claude Shannon and Shakespeare that were the same size was my goal, and JPEG is just what I arrived at. There are some complexities with the JPEG file format and the way that it compresses images that it complicates how simple it is. Like, it's not just bits and I mean, it's not just pixels and the intensity or the color at that pixel. It's a little more complex.
Did you get into like how the encoding works? Because like when you're talking about people's lives or so forth being like a random string number, we would only be able to interpret it if we could encode it correctly, right? So let's say you have an infinite stream of numbers. You can't understand the number sequence without encoding it.
That's
so,
right.
So what did you come across like anything interesting regarding like JPEG encoding?
No,
No?
not yet.
Just curious.
This is as far as I've gotten.
The something image seems to have only one color, right, in the portion that.
Oh, there's a reason for that. There's a reason for that. So a compressed file is a recipe to create the uncompressed file. So at the moment of damage introduced by the addition or subtraction, you've now caused the recipe to decohere.
Yes.
And then what's going to come out of that is going to be white noise. And then when you show the white noise, that's going to be black and white pixels randomly will show as 50% gray.
I was thinking about that, but look at the color pattern over there in the top right corner. It's
Yeah.
not just black and white, because at first thought maybe like subtraction and addition would result in like a null pixel, right? But I think it's a little more complicated.
It's salt and pepper.
No, it's more, look at the top right hand corner.
Yeah,
Oh yeah. Well, yeah. So as you approach the early stages of the damage, you know, the decoherence isn't so bad. And then it gets further and further off the rails till you get. Then there's the black area. Then you get the gray zone, which is where now the compression algorithm is just running, but it's just churning out effectively pseudo-random bits from then on. And so the pixels are going to be white noise.
Right,
So is it like a range as it like hits across
Well,
like
JPEG
the
has
damage?
tolerance to a
Was that-
certain number of like bits being flipped. So when it does that, it will just look a little fucked up. But like after a certain point, the entire decompression. is
Yeah.
done.
Alright.
Yeah.
I mean, why not use bitmap? That would be.
Yeah.
Yeah. I mean, then you'll just see the noise.
That-
It's like
that
an
would
analog
make-
television.
that would have made more sense.
Either way, I'm not sure.
I agree.
Probably not too many bitmap images of Shannon and Shakespeare of the same size on the internet.
Well, what you got to do is
That's-
you start with a JPEG. You then have to pick a format. So like I'd go like with an RGB, just bitmap, and then you've got to like size and crop them so that they are the same size, and now they're the same format. But then you run into the next issue, which is if the image you subtract is larger than the image you're subtracting from, now you're getting a negative number. And what does that mean? Well, you could just impose it to say, well, it's a fixed width and I'm doing 2's complement. But, or you wind up with an infinite number of 1 bits.
Yeah.
Yeah.
Did you try doing any of these operations with the same image, like adding the same image to itself or subtracting? Because I mean, considering, like you said, the JPEG compression or even like a lossless file, like a TIFF.
The problem
how
with
well it
lossless
works.
files is they have checksums, so you flip a bit and it's invalid.
Yeah, so the core of this talk came from an article I wrote. If you all would like to take the Python here and play with it yourself, you can find it here. So I'm the poet coder, GitHub, and it is essence and expression right there.
I would say he's peering over a concrete wall.
So yeah.
That's cool.
Yes.
Just as you were choosing a way to interpret any individual number, any random number, you could also choose to interpret the same number any infinite different ways.
Absolutely, absolutely. And there is something I learned about called a polyglot file, something
Yeah.
like that, where it's the same underlying binary, and you call it an Excel file, and you call it an MP3, and it's interpreted differently, but it's a valid file in both formats. There is that sort of thing. And
It's
so there's-
valid?
Yeah,
I
that it
mean,
would-
like here or valid?
valid, that it opens, that it doesn't immediately error out.
Right.
Do you mean like different formats that can be interpreted similarly? Is that what you mean?
I mean, that there exists the possibility that you could take a picture of me and then come up with a new way to interpret those bits such that it is an entirely different file format.
Same underlying bits, just
Same
maybe
underlying
maybe
bits.
add a header or footer here.
Well, I
I mean,
imagine.
it makes sense. I mean, you've got like, for each file format, and there's an infinite number of solutions for things that are valid for that file format. And you take the number line and you color that set with, say, the color green for format A. And then you take format B. And same trick now, all valid files, you're gonna go to the number line and color that with the color red. There will be the intersection set that's both green and red, shows up as yellow. Those will be polyglot files.
Okay.
That's exactly right, yeah. Yeah, pretty
It
wild.
can happen also with bash and batch in Windows. You can have one file that runs both operating systems.
Yeah, and there's tricks people do, like, you can take any zip file and you can put any prefix data at the beginning of it, and it's still a valid zip file because it's the footer of the file that defines the format. And extra data at the beginning is valid. So this gets used to have executable zip files that have shebang lines at the beginning of them. And Python supports that.
Oh.
Yes, it's called zip app.
Okay.
Sounds dangerous.
Yeah, it definitely is.
But it does not work with like compiled C extensions. It only works in pure Python stuff. There is a third-party library called Shiv that you could then bundle your Python application as a single zip file, but then it has to like uncompress the relevant parts to be able to run.
It's great.
That's cool.
Thanks for sharing.
Yeah, yeah, absolutely.
Other questions for our speakers? So I have one, if you don't
Yeah.
mind, scrolling back down to the bottom of the notebook you were showing. While you get the laptop plugged back in, I do want to say I was excited to get your email because there's like a special place in my heart for this genre of talk where it's like, what even is a number? And it doesn't matter if you think you know what a number is, like you always find out that you don't. So this is cool. If you could scroll like all the way to the bottom, there was a photograph you had.
Oh, yeah. That one?
So you look really old in that picture.
It's the last picture of me that's ever taken.
How did you take that?
Isn't that from Lost?
It is. That is. The actual quote is, I looked into the eye of the island, and what I saw was beautiful.
He ran the wild loop for like a couple days.
A couple days. I was wondering how long it took.
32 bits per pixel times 10, 19, 20 times 10.
Yeah.
For loop.
Yeah. Yeah, I mean, you can take this sort of thing in a lot of different directions, which is why I'm interested to tell people so you can take it in whatever direction is interesting to you.
So please join me in thanking our speaker one last time. All right, now for the next 30 minutes, we have time for